I'm that VB guy, and in this video I'm going to demo a prototype I've written that extends VBs for each loop with support for LINQ query operators, and talk about some of the reasons why it might be a good feature for a future version of the language. I'm going to start off with a fun but contrived demo, then I'm going to show you some of the analysis that I did that motivates the feature, and lastly I'm going to show you a real-world example of using the feature to refactor existing code. There's a big disclaimer in the description below, please read that. There's also a link back to the more detailed design proposal on GitHub where you can give your feedback, as well as find a link to a branch where you can play with the prototype yourself if so inclined. With that, let's get to the demo. So the principle of the feature is really straightforward. I have here a regular for each loop that loops over all the letters in my name and writes them out one at a time. It's not uncommon, however, with for each loops that you want to do some type of transformation on the data that you're looking at or filter out certain results. A great place to use the query operator where. So let's say I want to loop through my initials, or the uppercase letters in this string. There you have it. I use the where operator, and that's basically how the feature works. Of course, VB has more query operators than just where. I can also link through the distinct letters in my name. And you see that garble of letters. It filters out the extra in my first name, spaces, and things like that. But I can see that the first letter of my first name and the third letter of my middle name aren't considered the same, and that's because they're different casings. One way to solve this would be, of course, to just lower the entire string, but I can also transform the data before I filter it with distinct by using the select clause. If I run that, you can see correctly that A is only listed as appearing in my name one time. Or maybe I want to do something more interesting. I want to group all of the letters in my names into a count, and order that by the total count descending, excluding spaces, of course. Then I want to write out so the letter N appears the most in my name. Okay, that's fun. That's the principle of the feature. Now, let's go take a look at some code that analyzes source spaces and finds times where you can use this feature. This is a program I wrote called the Syntax Scanner. It uses the Rosin APIs to scan over a collection of source files written in Visual Basic and look for certain patterns in code that might lend itself to the use of a potential new language feature. In this case, here's a procedure I wrote that looks for patterns in for each loops where I could use the query extensions I just showed you. Specifically, it looks for each loops that either directly iterate over the results of a query expression or iterate over the contents of a local variable initialized with a query expression. And when I say query expression here, I mean using either the SQL-style query syntax or the extension method lambda syntax, and I've written this code to recognize both. Because it takes a little time to analyze all of the Rosin repo, I kicked this program off already so we can just look at the results. So you see here the program has printed out a list of examples that it found, and they illustrate the patterns that I was just talking about. Sometimes there are local variables initialized with expressions that use the extension method in lambda syntax. Sometimes the extension method in lambda syntax is used inline. Other cases use the query comprehension syntax. This example actually highlights another problem with using LINQ directly in Visual Basic today in combination with the for each loop. Because this local variable, local info, is in scope inside of the expression that you're for eaching into, you can't actually use that same name inside of this query expression. So the person who wrote this code had to come up with a dummy name, in this case I, to refer to the logical element, even though I, in this case, refers to an element of info the same way that local info does. You run into that same shadowing issue, regardless of whether you're using the query comprehension syntax or the lambda syntax. If you take this example again, you see the awkwardness of how this reads. For each local info in from I. For each in from, that's not very English-like. You can kind of get around this by using the query comprehension syntax, but now you're using symbols and even less English-like syntax. And you can get away from both of those by extracting things out into local variables, but then you're kind of highlighting the separation between the deferred execution model of LINQ and the imperative immediate execution model of the rest of the Visual Basic language. At the bottom of this list of examples, of which there are many, is a little report that tells me how often the scanner found these patterns in code. And it found 95 instances out of a total of 2,847 instances, or a little bit over 3.3%. But as I was looking through the results when I originally wrote this, I noticed other patterns in for each loops that weren't explicitly using LINQ, but which were doing things which logically could be expressed using LINQ. One of these cases I call the filtering for each loops, and have some modifications to look for them. In the interest of time, however, I'm going to kick off the program while I explain to you what a filtering for each loop is. A filtering for each loop is a loop that only contains one statement, either a single line or multi-line if, because it's a for each loop that conditionally executes for some elements and not others. This could logically be written as a where clause. Another pattern of filtering for each is a guard clause, a single line or multi-line if statement at the beginning of the loop, which conditionally exits the for using an exit for statement, or skips an iteration using the continue for statement. I use this pattern in my own code to avoid extra indentation, and it could logically be expressed using a skip while or a take while query operator. I've also written this so that it's okay if it runs into a local variable declaration, because those things could be written using the LINQ let clause and still let you use additional query operators after that. So, with those modifications running, let's go look at what the program found. As you can see, it found more examples. At the bottom, the report says that it found an additional 344 examples, raising our total to about 15.5% of all the for each loops in the Rosin codebase either directly use queries or use local variables that refer to queries, or have patterns that could be written using queries. Let's go look at some. You see now we have an example here that's just a for each loop, and the only thing that it contains is an if block. It's going through all the meta role info in a list of meta roles, and if that info is not the target and is not contained in a certain location, then it skips it. This could be a where clause. You see a lot of examples like that where they're just simple if blocks. Here's a big meaty example. Here's some code that actually is the implementation of how the compiler hooks up handles clauses. It's actually going through all of the declarations inside of a type, looking for certain methods, looking for ones that handle events, and performing some logic based on that. In the next example, I'm going to show you how we can take this block of code and refactor it to use the feature that we've been discussing. So here we have the code that we were just looking at in the syntax scanner. This is a for each loop that's in the actual Visual Basic compiler in the Rosin solution. And it's actually the code that generates all the magic code that hooks up events when you use a handles clause inside of like your WinForms or WPF app. So the way that it works is it goes through all of the members in a containing type. It finds the ones that are methods. It looks for the ones that have any declared events that they handle. If they're a partial method, it goes and gets the implementation part and it merges those handled events. Then it goes through all the events that are being handled, and for each one of them generates an add handler statement that it adds to your constructor body. It's pretty straightforward code, but the implementation, the real meat of the code rather, is inside this section right here, this group of sections here where we actually create the statement and we add it. All the rest of it is just kind of boilerplate, helping us filter down to the ones that we really want. It's a prime example of a place where you could use our feature and then kind of eliminate some of this unnecessary indentation and hopefully make the code a little bit clearer. So let's do that. So I'm going to go here, and starting out with this if statement, this can be a where clause. That's pretty simple. There we go. And then these local variable declarations, they can be changed into let statements or let clauses. And of course, so can this continue for statement inside of this loop. It just skips the element, and so that could be written as a where clause. Now this next part is a little tricky. It's actually conditionally concatenating the implementation part if it exists, but it's also filtering for the case where you have a partial that doesn't have an implementation, because you don't need to do anything for that. I happen to know that I can simply replace that by saying, and also, not method.isPartial without implementation, and the next part, the reassignment, that's a little bit tricky. So here, what we actually need to add is a select that creates a new handled events range variable that is conditionally populated. First, we're going to say not method.isPartial, because that's the common case. We just want to get the handled events as they are. But if it is partial, and since we know from that where clause already that we have an implementation, then we can say handled events.concat method.implementation part handled events. And that's the equivalent code to what we just saw. Then we have this next section here where there's a nested for each loop. And that can really be expressed as a cross join, which is something you might know from SQL, which is taking the elements of one collection and combine them with another, also known as LINQ as select many, which is represented by another from clause. I can say from handled event in handled events that is actually the same as this nested stuff. And then finally, there's another filter in here that says where this handled event hookup method is the correct hookup method kind. So this makes sure that you're injecting the code in the correct constructor of the right kind. But that's just another where clause. So now we can take all the code that was originally inside of this nested for each loop, and we should be able to paste it right here and have it still work. We can take all of this stuff here and just delete it. So that's the same code that we were working with before, except now, as you can see, it's not nearly as deeply nested as it was before, and it's a lot easier to read exactly what the code is doing in a declarative manner. It's just going through every member in the containing type, that's a method, getting the method, looking at the handles events, making sure the handles events aren't empty, and that it's not a partial method without an implementation, merging those things as necessary, then going through each of the nested handle events, where the hookup type matches, and then performing this set of code. I think that's a lot clearer, and at least it fits on one screen. And of course, because it's LINQ, I can also free format this to look however it is that I want. So there you have it. Less indentation, shorter code, more declarative, and a natural progression from using the for each style that everyone's used to actually using LINQ without having to kind of completely branch into a different version of the language. If you like what you've just seen here, there's a link to the more detailed description of the design proposal on GitHub below. You can give your feedback there, and you can play with the bits yourself. Feel free to leave me a comment and let me know what you think, and of course share with your friends and fellow developers, because I want to know what they think as well. Thanks.